Hello friends, welcome to all to a new lecture on SSB lecture solution 2021 physics. Okay, and in the continuation of that lecture series, I have already done the first one as a warm up. Okay, you must have remember that I have done the first question. Okay, so in this video, I am starting from question number 2. Okay, so this is the question number 2, and this was already done the first one. Okay, so read the question number 2. In the question number 2, there are three vectors fields are given. The first one is this vector A, vector B is this, and vector C is the this one. Okay, and we are asked to determine whether all all these given fields are a magnetic field or any particular fields is a magnetic field. So how can you find whether a field is magnetic field or not? It's simple. How can you find? We have to apply the second Maxwell equation. Okay, you know the second Maxwell equation, del dot B should be 0. Why? This should be 0, del dot B. Why? Because magnetic monopole does not exist in the universe. Okay, that's why del dot B is always 0. Okay, so we should have to apply this concept, or we can say this formulation on this question. Okay, so let's apply. You see, these are three fields. Okay, so let's apply this concept, this formula of second Maxwell equation one by one. So if you apply del dot A, if you calculate del dot A, it will give 0. How? Sorry, if you apply del dot A, then this A is x I cap minus y j cap plus z k cap, and this del operator is I del by del x plus j del by del y plus k del by del z. Okay, if you apply this on this vector A, you will get positive 1, negative 1, positive 1. So 1 and positive 1 will be cancelled out, then you will get only 1. So as it is not becoming 0, that means what? Del dot A is not becoming 0. That means what? That means this A field, this field A is not a magnetic field. Okay, magnetic field, whether it is static or it is varying with a position and time, in all the situations it is always 0. Okay, magnetic field, that means if a wire, if there is a wire, okay, this is a infinite wire, okay, and current is flowing inside it. Let's suppose this is I. Okay, and this current is steady, that means it is not changing with time. So at every position, let's suppose at this this line, take an imagine line. Okay, or you can say imagine it in an cylindrical imaginary cylinder. Okay, at every point on this surface, on this cylindrical surface, the magnetic field is 0. The field has can have many direction. Okay, because it is tangent to that point. Okay, but the magnitude is same. Okay, that means it is not varying. Okay, but if the current is changing, then in that case you will get what? Variable magnetic field. Okay, but in both the situations, whether it is varying or the magnetic field is constant, in both the situations, the del dot B operation is always 0. But here, if you apply this del operator on A vector, then you will not get 0. That means A is not a vector field, or you can say A is not a magnetic field. Okay, so now let's apply on B vector. If you apply on B vector, if you see, this is the B vector. Okay, x I cap plus y j cap minus 2 z cap. Okay, if you apply this, then you will get 1 plus 1 minus 2. So definitely it will give 0, because 1 plus 1 equal to 2 and minus 2 is there. So it will be 0. That means vector B is a magnetic field. Okay, similarly apply the del operator on C vector, then you will get a 0, because if you see x plus x minus y and there is no variable for z component. Okay, there is the z component is constant because only z cap is present here. Okay, there is no z variable. Okay, so that's why the derivative of a constant quantity is always zero. That's why this zero is present here. Okay, for z component. Okay, so that's why 1 minus 1 equal to 0. So this magnetic field C is also a magnetic field. That means how many vectors are belongs to magnetic field? Vector B and vector C. Okay, you see vector B is also 0, del dot B equal to 0, and vector C for C also, del dot C is also 0. Now if you come to the options, you see which option is correct. A, B, B, C, yeah. Yeah. Option B is the correct one. B and C both may represent the magnetic field. Okay, option B is the correct one. So now coming to question number 3, it is given that a particle of mass m 0.1 kg is initially motionless on a frictionless surface. There is no friction. Okay, and initially at time t equal to 0, the particle is at a rest. That means u equal to 0, initial speed equal to 0. There is no friction. That means there will be no work done for frictional force as the surface is frictionless. Okay, and it is given that at a t equal to 0, an impulse is impacted to the block and it starts moving on the surface with a uniform acceleration, and the acceleration is 10 meter per second square, and we are asked to find the action at t equal to 1 second. Okay, so what is impulse? Impulse is force times the time duration. Okay, force into time, that is the unity. Okay, so we are asked to find the action. So how can you find? Let's see the solution. Now you see the mass is this, and the initial speed is 0. Initial speed is 0, and the acceleration is 10 meter per second square. Okay, now let's suppose the particle is initially at a position A. Okay, this is the position A, initial position at a time t equal to 0, and at a time t equal to 1 second, the particle is reached this point B. Okay, so we are asked to find the action in this time interval A to B. Okay, so what is the action? Action is the integral from time t1 to t2. That means this is the initial time and t2 is the final time. Integral of Lagrangian into time interval dt. Okay, where this L is the Lagrangian. Okay, and the Lagrangian is denoted as t minus b. What is t? What? This is the kinetic energy, and this b is the potential energy. So t minus b is the Lagrangian. And how to find the kinetic energy? Kinetic energy is nothing but half mv square, and this b is the final, or you can say at any time the speed of that block. Okay, now this v can be calculated from the equation of kinematics. If you apply the Newton's equation of kinematics, v equal to the first kinematics equation. Okay, so v equal to u plus at. Then as the initial speed equal to 0, so v will be nothing but at. Now if you put this equation, the value of equation 2 in the equation 1, then you will get t equal to this kinetic expression of this is the expression of a kinetic energy, half m a square t square. Now let's find the potential energy. Okay, the potential energy is nothing but the negative of work done. I have seen in many YouTubers has neglected this potential energy, and they have told that this potential energy is 0 because it is the particle or the block is present in the reference level. That means at the ground. So as it is present on the ground, so height equal to 0, so mgh equal to 0. That means potential energy equal to 0. But we should not do like this, because we have to take the work that has been done throughout the motion. That means from this to this, there will be a work done from point A to B. So that work done should be taken into consideration because work done is negative of a potential energy. Okay, so if you take that concept, the potential energy is negative of a work done. Work done is force into displacement. Let's suppose this is the x is the displacement and force is equal to mass into acceleration. And how can you find the position or the displacement? Displacement, if you apply the again the equation of kinematics, there are three equations of kinematics. So among them, this position x equal to ut plus half at square is one of them. Okay, so if you find x, so if you put what u equal to 0 because initial speed equal to 0, so then you will get a half at square. And if you put this value of equation 4 back to the equation 3, then you will get v equal to minus half m a square t square. Okay, then your Lagrangian will be t minus v equal to half a m a square t square minus half m a square t square. Then you will get m a square t square. This is your Lagrangian. Okay, now if you put your time from 0 to 1, because in this interval we are asked to find the action. Okay, then if you put the Lagrangian value m a square t square and dt, and after that you have to do the integration. Okay, from 0 to 1, then you will get this. You see, this is a simple derivation. Okay, so you will get 10 by 3. Okay, but in the question there is no such options among the, you see, in these 4 options there is no such option of a 10 by 3. Okay, so actually this question should be given grace mark, but I have seen the answer key of this particular 2021 physics paper. In that answer key, in the final answer key, there is no grace mark to the question, and option D was given the correct one. Okay, I don't know why. I think they have not taken this question seriously. Okay, so that's why they have skipped, I think. Okay, but if you have done many questions in GET, okay, then you will see that there is in 20, I think in 2016 there was a question, okay, similar to this. If you see, I can show this question, okay, to you. Okay, you see, this is the GET 2016 paper. Okay, GET 2016 paper. You see, this is the 2016 paper. Okay, GET 2016. Now in this paper there was a question in question number 35. If you see, there is a question number 35. Yeah, this is the question number 35. You see, a particle of mass m, this initially is at rest at origin. It starts moving with a uniform acceleration. That means uniform acceleration means what? A force is applied on that particle, and that's why the impulse has been created. Okay, so you don't see there is no impulse term in this question. No, the both questions are same. There is some wording mismatch. Okay, there is a mismatch in the wording, but don't see that this question is not equal to that question in the SSB. Okay, both questions are same. Okay, so wording is different, and we are asked to find the action at a t equal to 2 seconds. And if you find the answer of this question, you will get the right answer is 26.66. Okay, 26.66 joule into second is the correct one. And if you see the official answer key of this GET 2016, then if you see 35 number question, you see 35 number question has given 26.65. Okay, the right answer. Okay, so now coming to question number 4, it is given that a particle of mass m and angular momentum L is moving in an attractive potential UR equal to minus alpha by r square, where alpha is a positive constant of appropriate dimension. It may reach the center of force due to the potential here. If actually here we are asked to find the value of alpha. Okay, alpha is a positive constant, so that it may reach the center of force. Okay, so how to find? Let's see the solution. You see, the potential is this. We can find the value of alpha by applying two formula. The differentiation of a first derivative of a v effective and the second derivative of a v effective. So make first derivative of a v effective as 0, and for stability concept, we have to apply del square v effective by d r square greater than 0 for stability condition. Okay, so if you apply both formula, then you will get alpha equal to L square by 2m for this case, and for stability case you will get you see, this is a simple derivation. Okay, it's nothing but only derivation. Okay, plus 2 physics mathematics. So if you apply this and you derive this, you will get alpha equal to alpha smaller than L square by 2m. If alpha smaller than L square by 2m, that means what? Alpha greater than minus L square by 2m. Okay, for if you not understand, let's see. Okay, I have considered that alpha equal to 2. You see only this part, only focus on this part. Okay, here I have taken alpha equal to 2, alpha equal to 2. Okay, let's say L square by 2 equal to 3. So 2 smaller than equal to 3. Okay, you put this value of alpha and L square by 2m in this part. Okay, then 2 smaller than 3. Okay, so if 2 smaller than 3, can you say that 2 greater than equal to minus 3? So that concept is used here. So that's why this alpha is becoming greater than L square by 2m. Okay, and also it is mentioned that in the question it is mentioned that alpha cannot be is a positive constant. You see the question. Alpha is a positive constant. Here alpha is a positive constant. That means what? It cannot be negative, cannot be 0. Okay, so that's why which option is correct? Option C is the correct one. Now coming to question number 5. It is given that at a time t, two electric charges are at a distance r. The distance between them is r dash at a time t dash. Okay, the equation of motion allows a series of similar paths if t dash by t equal to r dash by r to the power beta, and here we are asked to find the value of beta. Okay, so how can you find? Let's see. This is the situation. Okay, we don't know whether this q and are positive or negative. Okay, for sake of simplicity, let's suppose this is a heavy particle on which q charge is present, and this is a light particle on which, let's suppose this is a negative charge, and this is a light particle, and this light particle is being attracted by this large mass particle whose charge is q. So as this is positive charge and this is a negative charge, so this negative charge is coming towards this positive charge. Why this positive charge is not coming towards negative charge? Because this positive charge has a large mass. Okay, for simplicity, let's. So what is the force on this light charge whose charge is minus q? You see, both have same charge, but among them this negative charge particle has a lighter mass compared to this positive charge. Okay, this is a massive particle, let's suppose. Why I am taking this as massive particle? So that it will be remain at constant. Okay, so as it is a massive particle, that means the force acting on it will not generate a larger momentum. Okay, so as it is not, as it cannot create a larger momentum, so it will not move. And if it moves, then it will not move in a significant manner as this negative charge move. Okay, so the force on this negative charge will be how much? FBA means force on B by A. By A means the charge particle which is present at the point A. Due to that charge particle, the force is acting on this charge particle which is placed at point B. This is the point B. Okay, that means this force is acting on this negative charge. Okay, so this is a attractive force. Okay, if you take this as positive x direction, then the direction of force is in that direction, in the opposite direction of x axis. So that's why this negative sign is taken here. So the force is k q square by x square. X square is the distance between the q positive charge and q negative charge. You see, in the question it is not mentioned whether this charge are positive or negative. Okay, for your sake of simplicity, you can take it. Okay, and there is also there is no concept of larger mass or smaller mass. It is just an intuition. Okay, that you can take. Okay, for simplicity. Okay, to make your derivation very simple, because what you have to determine, we have to determine the only the ratio. Don't see the whether the mass is larger or smaller. Okay, force is force. It is always acting on the larger mass or smaller mass in the equal amount. Okay, so let's see. So as this force equal to this much, so we can place this at the place of force as mass into acceleration. What is this acceleration? Created due to this force. Okay, and the mass is the mass of this particle, this negative charge particle. Okay, now mv equal to dv by dt. You know, acceleration can be written as v dv by dt. How? You see, acceleration equal to dv by dt. Okay, so acceleration can be dv by dx. So dx term is divided here and dx term is uh, multiplied in the numerator here. Okay, so dv by dx and dx by dt, this term will be v. Okay, how? Because velocity equal to position by time, so that's why this term become v. So v dv by dx, sorry, this is not dt, this is dx. Okay, so this is used here. Okay, you see, this is used here. Okay, this is used here. So m v dv by dx equal to minus alpha by x square. I have taken this as this is a constant quantity k q square, so I have taken as this is as alpha. Okay, this is a constant. Okay, so mv dv equal to minus alpha dx by x square. Okay, now integrate both sides, you will get mv square by 2 equal to positive alpha by x plus c. Okay, now this c is the integration constant. C is an integration constant. So how can you find? Just put the boundary value. What are the boundary value? X equal to infinity, because at a initial position, at a initial time, let's suppose both charges are placed at infinity. That means they have a gap of the distance between both charges is infinity. So when x equal to infinity, and at that time there was no force on them, so v equal to 0. That means the speed of that negative charge at the initial time, okay, is equal to 0 at that time. So if you put x equal to infinity and v equal to 0 in this equation, you will get c equal to 0, because alpha by infinity is 0. 1 something divided by infinity equal to 0, and this is also 0, v equal to 0. So 0 in the left side, and in the right side this term is also 0. So c equal to 0. Hence equation 1 becomes, now if you put c equal to 0 in this equation 1, you will get mv square by 2 plus alpha by x. Okay, now v square will be this, v will be this, then v will be this, and this term is a constant term, so I have taken this as constant k. This constant k. Okay, this is a constant k. And if you put the value of a v, that is dx by dt, and you again integrate it, then you will get a, you see, this is nothing but plus 2 integration. Okay, mathematics. Then you will get a t equal to this. Okay, and this is constant, again a constant. So what you have to find, we have to just see, we have to just take the dependency, how t depends on x. So you can see t depends on x as 3 to the power 2, power of x to the power 3 by 2. So t dash by t equal to x dash by x will be 3 by 2. That means the beta value is, how much? 3 by 2. Okay, so this is the beta value. So hope you got the answer of all question. Thanks for watching.